Good afternoon, all. This is Satish Kumar, Assistant Professor of EC Department. Now, let us see the another video lecture series on FIR filter design using windowing techniques. The windows are the finite duration sequence used to modify the impulse response of the FIR filter in order to reduce the ripples in the pass band and stop band to achieve the desired transition from pass band and stop band. The different types of windowing techniques are rectangular window, Hanning window, Hamming window, and a Blackman window. Now let us see the rectangular window and the Hanning window sequence. Rectangular window, the features the width of the main lobe width is equal to 4 pi by n. The maximum side lobe magnitude is minus 13 dB. The side lobe magnitude does not decrease significantly with increasing omega. Now we can see the features. The width of the transition region is related to the width of the main lobe of the window spectrum. Gibbs oscillation are noticed in the pass band and stop band. The attenuation in the stop band is constant and cannot be varied. Rectangular window can be defined as WR of n is equal to 1 for minus n minus 1 by 2 to plus n minus 1 by 2, 0 for other n. Else, WR of n is equal to 1 for 0 to n minus 1, 0 for other n. This is the rectangular window sequence for n is equal to 31. While we taking the amplitude response of the rectangular window, we can get it like this: n is equal to 31 with respect to normalized frequency and normalized amplitude. Now, for that the magnitude response of the rectangular window, we can get it as your 4 pi by n as your normalized frequency with n is equal to 31. While we taking the log magnitude response of the rectangular window, we can take it as your minus 13 dB with respect to normalized magnitude and normalized frequency. Now we can see the Hanning window. The width of the transition band depends on the type of the window. The width of the transition band can be made narrow for by increasing the value of n, where n is the length of the window sequence. The attenuation in the stop band is fixed. Features is the main lobe width is equal to 8 pi by n. The maximum side lobe magnitude is minus 31 dB. The side lobe magnitude decreases with increasing omega. It can be defined as omega c of n 0.5 plus 0.5 cos of 2 pi by n divided by n minus 1 for n is equal to minus n minus 1 by 2 to plus n minus 1 by 2. 0 for other n. It else Wc of n can be defined as 0.5 minus 0.5 cos of 2 pi n by n minus 1 for n varies from 0 to n minus 1, 0 for other n. This is the Hanning window sequence with respect to omega Cn and En with n is equal to 31. While we taking the amplitude response of this Hanning window sequence, we can get it as the waveform like this with respect to normalized frequency and amplitude. While we taking the magnitude response of the Hanning window, we can get as 8 pi by n as the normalized transition region of this particular Hanning window. While we taking the log magnitude response of this Hanning window, we can get the response as your minus 31 dB will be the log magnitude response of the Hanning window. Now, desired impulse response of FIR filter design using windows for low pass, HD of n is equal to 1 by 2 pi integral over minus pi to pi HD of e power j omega into e power j omega n into d omega. See, limits for low pass filter can be varies from minus omega c to plus omega c. HD of e power j omega can be defined as e power minus j omega alpha. Right? In case of high pass, the limits will be vary from minus pi to minus omega c to pi. Therefore, 1 by 2 pi minus pi to minus omega c e power minus j omega alpha e power j omega n into d omega plus 1 by 2 pi omega c to pi e power minus j omega alpha e power j omega n into d omega. In case of band pass, limits varies from minus omega c to minus omega c1, omega c1 to omega c2. In case of band stop, minus pi to minus omega c2, minus omega c1 to plus omega c1, omega c2 to pi. Remaining all other limits are 0. Now we can see the FIR filter design using windows for symmetric condition. Symmetric condition h of n minus 1 minus n is equal to h of n. First we can choose the desired frequency response hd of e power j omega, which is equal to c into e power j alpha omega. C is equal to constant, alpha is equal to n by 2. Omega c for low pass and high pass, omega c1 and c2 for band pass and band stop. Next, number of samples will be impulse response will be n. Next one, determine the desired impulse response HD of n by taking inverse Fourier transform of desired frequency response HD of e power j omega. How to find the HD of n? 1 by 2 pi integral over minus pi to pi HD of e power j omega into e power j omega n into d omega. Next one, choose the desired window sequence defined for n is equal to 0 to n minus 1. Now multiply h of n is equal to hd of n into fixed window sequence or w of n. Limits varies from 0 to n minus 1. Now we can take in the inverse Z transform of impulse response h of n to get the transfer function h of z of the filter. H of z is equal to Z transform of h of n is equal to summation n is equal to 0 to n minus 1 h of n into z bar minus n. Then finally we can solve the suitable structure for realization of FIR filter. Now we can see the comparison. The width of the main lobe in window spectrum is 4 pi by n in rectangular window, 8 pi by n in handing window. The maximum side lobe magnitude in window spectrum is minus 30 dB in rectangular window, minus 31 dB in handing window. Minimum stop band attenuation is 22 dB in rectangular window, minimum stop band attenuation is 44 dB in handing window. Now we can see the assessment. The windows are finite duration sequence used to modify the impulse response in order to reduce the ripples in the stop band and pass band. List the types of windowing techniques: a rectangular window, handing window, hamming window, Blackman window. Gibbs oscillations are noticed in the pass band and stop band. Define rectangular window 1 for n is equal to 0 to n minus 1, 0 for other n. How to calculate desired impulse response HD of n? HD of n is equal to 1 by 2 pi integral over minus pi to pi HD of e power j omega into e power j omega n into d omega. Compare rectangular and the handing window. Rectangular, the width of the main lobe is 4 pi by n. The in handing window, the width of the main lobe is 8 pi by n. Stop band attenuation is 22 dB in rectangular window. Stop band attenuation is 44 dB in handing window. Thank you.